Imagine this. What if the stars you're looking at tonight are already dead? The light reaching your eyes could be millions, even billions of years old, which means every time you look up at the sky, you're not seeing the present, you're looking into the past. But that raises a deeper question. If we're always seeing the past, what is actually happening out there right now that we haven't seen yet? And what if something out there is looking back at us? In recent years, space science has advanced faster than ever before. With tools like the James Webb Space Telescope, we're not just seeing farther, we're seeing the universe with a level of clarity humanity has never had. And the result? The more we discover, the more we realize how little we truly understand. Let's start with something simple. The universe is expanding. But here's the strange part. It's expanding faster over time. Logically, gravity should slow everything down. Galaxies should gradually pull each other closer, or at least resist the expansion. But instead, they're accelerating away from each other. Why? Scientists call it dark energy. The problem is, we don't actually know what it is. Roughly 68% of the universe is believed to be made of dark energy. That means nearly 70% of everything that exists is something we cannot see, cannot touch, and cannot fully explain. So here's the real question. How can we claim to understand the universe when most of it is still a complete mystery? Now let's go deeper. We often think of space as empty, but it's not. Between galaxies lies something called dark matter. Unlike dark energy, dark matter has mass. It exerts gravitational pull. In fact, without it, galaxies as we know them wouldn't even hold together. But here's the catch. We've never seen dark matter directly. We only know it exists because of how it affects other things. It's like seeing footprints in the sand without ever seeing what made them. So again, we're forced to ask, are we truly observing reality or just its shadows? Now here's where things get even stranger. Black holes. For a long time, black holes were just theoretical. Predictions based on Einstein's equations. But today, we've not only confirmed their existence, we've actually captured images of them. But what exactly is a black hole? It's a region in space where gravity is so intense that nothing can escape. Not even light. Anything that crosses its boundary, called the event horizon, is gone forever. But what happens inside? We don't know. The laws of physics as we understand them break down. Time itself begins to behave differently. To an outside observer, objects falling into a black hole appear to slow down, almost freezing in time. But for the object itself, it falls in instantly. So which one is real? This isn't science fiction. This is actual physics. And it leads to a disturbing possibility. What if time isn't absolute, but something that depends on where you are? Now consider this. The observable universe is about 93 billion light-years across. But that's just the part we can see. Beyond that, we have no idea. There could be more galaxies, more structures, maybe even entirely different laws of physics. Or nothing at all. We simply don't know. And here's the most unsettling part. Even if something massive is happening right now, millions of light-years away, we won't know until its light reaches us, which could take millions of years. So technically, we are always behind, always observing echoes, never the present. And then there's the biggest question of all. Are we alone? With hundreds of billions of galaxies, each containing hundreds of billions of stars, the odds suggest life should exist elsewhere. Yet we found nothing. No signals, no confirmed contact, just silence. This is known as the Fermi paradox. If the universe is so vast and so old, where is everyone? Are we early? Are we alone? Or is there something out there deliberately staying hidden? Some scientists believe we might not be advanced enough to detect other civilizations. Others suggest a darker idea, that advanced civilizations tend to destroy themselves before they can explore the stars. If that's true, then what does that say about our future? The deeper we look into space, the more it begins to feel like a mirror, reflecting not just the universe, but our own ignorance. So next time you look up at the night sky, remember this. You are not just looking at stars. You are looking at time itself, at mysteries we don't understand, at questions we may never answer. And maybe something out there is looking back. Welcome to the universe, where every answer only leads to a deeper question. But let's push this even further, because everything we've talked about so far, dark energy, dark matter, black holes, still exists within the universe. Now ask yourself this: what is the universe expanding into? If everything is expanding, there must be space to expand into, right? Surprisingly, the answer is no. According to current physics, the universe isn't expanding into anything. Space itself is stretching. Galaxies aren't moving through space like bullets. They're being carried apart as the fabric of reality expands. But if space itself can stretch, what is space made of? And what exactly is nothing? This leads us to one of the most uncomfortable ideas in modern physics. The vacuum of space is not truly empty. Even in empty space, particles constantly appear and disappear in what scientists call quantum fluctuations. Tiny bursts of energy popping in and out of existence. For a brief moment, something comes from nothing and then vanishes again. This has been observed, measured, proven. So now we have a serious problem. If nothing can produce something, then what does nothing even mean? Now let's go back to the very beginning, the Big Bang. We're told that around 13.8 billion years ago, the universe began from a single, infinitely dense point. Everything, matter, energy, space, and time, compressed into something smaller than an atom. Then suddenly, expansion. But here's the part that doesn't make sense. What caused it? What triggered the Big Bang? Science can describe what happened after the first fraction of a second. But before that, silence. No equations, no clear answers, just theories. Some suggest there was a prior universe that collapsed and rebounded. Others propose a concept called the multiverse, that our universe is just one of many, constantly forming and disappearing like bubbles. If that's true, then our entire reality might be just one small piece of something infinitely larger. Now think about this. If there are multiple universes, do they have the same laws of physics, or completely different ones? In another universe, gravity might be stronger. Time might flow differently. Matter as we know it might not even exist. And if even one constant in our universe was slightly different, life would be impossible. No stars, no planets, no chemistry, nothing. So why does our universe seem perfectly tuned for life? Is it coincidence or something else? Now let's zoom back in, not to galaxies, but to you. Every atom in your body was forged inside a star. Hydrogen fused into helium, helium into heavier elements. Then, when massive stars exploded as supernovae, those elements were scattered across space, eventually forming planets and life. Which means, quite literally, you are made of stardust. But here's the twist. The atoms in your body are billions of years old, older than Earth, older than the Sun. So in a way, you are the universe, observing itself. But if that's true, why are we conscious? Why does the universe, through us, have awareness? Consciousness remains one of the biggest unsolved mysteries. We can map the brain, measure electrical signals, identify patterns, but we still don't understand why subjective experience exists at all. Why do you feel? Why do you perceive? Why is there something it's like to be you? Some scientists have begun asking a radical question. Is consciousness a result of the universe or a fundamental part of it? In other words, did consciousness emerge from matter, or did matter emerge within consciousness? It sounds philosophical, but this question is starting to overlap with real physics, especially in quantum mechanics. Because at the quantum level, reality behaves very differently. Particles don't have definite positions until they are observed. They exist in probabilities, multiple states at once, until something measures them. This is known as the observer effect. So the act of observation seems to affect reality itself. But what counts as an observer? A human mind? A measuring device? Or something else entirely? Now connect that idea with everything we've discussed. A universe made mostly of unknown energy, invisible matter shaping galaxies, time behaving differently near black holes, particles that don't exist until they're observed, and consciousness still unexplained. At some point, you have to ask, are we discovering the universe, or are we uncovering something far stranger? Because the deeper we go, the less solid reality begins to feel. Not fake, but incomplete, like we're only seeing a small layer of something much more complex. And maybe the biggest question isn't just what is out there, but what are we really a part of? So the next time you look up at the sky, don't just see stars, see questions, see uncertainty, see the edge of what we know and the beginning of everything we don't. Because the universe isn't just a place, it's a mystery that keeps expanding faster than our ability to understand it. And maybe that's the most fascinating part of all.